Hello guys, and let's continue solving the revision sheet. Here we have question number 10, and question number 10 is about the dilation, and we're given two figures A and B, and we are required to find out the value of each variable. So let's start with number 1. Okay, here we're given two figures, and we have the red figure is the image and the blue one is the pre-image. So once you have to find out the required, which is M, there's a rule when you're dealing with dilation in order to find out the missing part of a polygon or missing part of a triangle, for example, and also to find out the scale factor. This rule is image over pre-image. This is the scale factor. If you're required to find out the scale factor of the dilation, you can find it out by the relationship. The scale factor equals image over pre-image, or simply the image length over the pre-image length. And this proportional relationship also can help to find out the missing parts of any polygon. Okay, image over pre-image equals also image over pre-image. So let's apply this relationship. So here, guys, we have the red figure is the image. So since we have to find out the value of M, so M over the corresponding side in the original figure, which is 2, must equal the image from the center of, the length from the center of dilation to the image, which is 20, over the pre-image length, which is C, to the pre-image, which is 8, and by cross multiplication you find out 8m equals 40, and by dividing by 8 both sides you will find out m equals 5. So the required is 5. And to solve the second part of the question, which is B, you can also apply this proportional relationship, which is image over pre-image equals image over pre-image. And let's apply this out. So I know that the red figure is the image. So n over its corresponding side from the original side, which is n over 4, must equal image length, which is the image from this one, which is 3 over 6. Okay, and by applying cross multiplication you will have 6n equals 12. By dividing by x you will find out n equals 2. So this is the required, n equals 2. Question number 11 is also about the dilation, but here we are required to find out the scale factor of the dilation. Okay, so guys, you need to differentiate between two things. Which figure is the original figure or pre-image, and what figure is the image? Okay, so every time you will have this letter prime, P prime, it refers to the image. So this one in red is the image, and simply this because we have P prime, but the original shape will be a capital letter without dashes. So B is the original shape, and P prime refers to the image. In order to find out the scale factor, you need to apply this relationship. Scale factor, which is K, equals image length over pre-image length. And pre-image is simply the original shape. So, in order to find out the scale factor equals image length, and we are required to find out what is the distance from the center of dilation to the image, and it's given, which is 10. Okay? Pre-image is simply the distance from the center of dilation to the original shape, which is 5. So it will be 2 over 1, and the scale factor equals 2. And since we have the scale factor is greater than 1, so the dilation is an enlargement. And simply you can figure it out from the figure. The shape in blue has become larger and has become the image which is greater than the original shape. So here we have an enlargement, and the scale factor equal 2. And that means the blue shape, the original shape, has become 2 times larger by this dilation. So, for example, if I told you that this side, which is B, for example, BQ, equals, for example, 2 centimeters. So, the corresponding side, which is P prime, Q prime, equals 4 centimeters, because the scale factor of the dilation is simply 2. Okay? And the second part of the question also has the same idea, so let's go further and solve question number 12. And now let's go further and solve question number 12. And question number 12 is about the surface area of the square pyramid. Okay? The figure below illustrates a right pyramid with a square base. The length of each side of the square is 6, while the slant height, which is from the center of the side to the top, is 10. And these information are already given and are plotted on the figure. What is the combined surface area of the faces of the right pyramid below, excluding the base? Okay, so you need to exclude the base. Simply, we can find out the lateral area. So here we were asked about the lateral area of this pyramid, since we need to exclude the base. Okay, how to find out the lateral area of this pyramid? We have a rule to find it out, but I need to think here with you. Here we are required to find out the area of the 4 faces of this pyramid, okay? And we don't have to calculate the area of the base since it is not required. So what if we have to let's try to unfold these faces. Let's unfold this pyramid. So if we can just cut these faces and unfold them. Okay, this is a face and this is the second face. Okay, that one. Let's cut them out. So let's see what we are going to have. So the base will be like this. This is the base of the pyramid, and it is a square. So the first face, which is a square, which is a triangle. Okay, and this is the second one. I just want you to imagine what is the required. We need to find out the area of these all faces combined, and every face of these four faces is a triangle with a base length of 6 and a height of 10, and this is required. So the area that we need to find out is simply the sum of the areas of all these identical triangles. So simply you can find out the area of one triangle. So the area of triangle simply equals half times base times height. So the area of one triangle equals half multiplied by base, which is 6, multiplied by height, which is 10, and that equal to 30. So this is 30 units squared, the area of one triangle. And we need to find out the area of all these triangles combined, and that form the lateral area of the pyramid. So simply multiply the area of one face by 4. So the surface area will be surface area excluding the base, which is the lateral area of this pyramid, equals the area of one triangle, which is 30, multiplied by 4, which is the number of identical triangles that form this square pyramid, of course, with the base. It will be 120 units squared. This is the area of this pyramid excluding the base. We can also apply the formula for the lateral area, and we know that the lateral area of the pyramid equals half times the perimeter of the base multiplied by the slant height, which is L. Let's substitute for that. Half multiplied by the area of the base. We know that the base is a square, and the perimeter of the square equals 4 multiplied by side length, which is 4 times 6, and that multiplied by the slant height, which is 10. Okay, so half multiplied by 24 multiplied by 10, and that simply equals 120. So you can find out the answer by using more than one method. Okay, let's go further and think about how to solve the question number 13. And question number 13 is about the relationship between the interior angles of a triangle and the relationship between it and between them and the exterior angles of the triangle. Here we are required to find the value of this angle. Okay, in order to find this out, you need to get benefit from the given information and try to find out more information and plot them in the figure. Okay, so we know that in this triangle X, Y, Z, the sum of the interior angles of any triangle add up to 180 degrees. So we can find out the measure of the angle XZY, and simply equals 180 minus the sum of 110 plus 45, and that equals 25. So the first piece of information we need to add to this figure is the measure of angle XZY, which is 25 degrees. And also we are given that this is the polygon is a trapezoid. Okay, and we know that the trapezoid has one pair of parallel sides. So these sides actually are parallel. Okay, so this one is parallel to that one, and that means once you have this transversal, so you think about two congruent angles. This angle which measures 25, and that angle also measures 25, because these two angles are alternate interior angles. Okay, so in the triangle WXZ, we're talking about this triangle so far. We're talking about this triangle. I could find out the value of this angle, which is 25 degrees. Okay, how can you find out the value of this angle? Angle VWZ simply is an exterior angle. Exterior angle of the triangle WXZ. So the measure of the angle, I will call it angle M. Okay, the measure of angle M equals the sum of the two non-adjacent angles. Okay, and you can find out the measure of angle VWZ equals the sum of the measures of the two non-adjacent angles, which are 15 plus 25, because this angle is an exterior angle of this triangle, and that equals 40 degrees. So this measure, the required, equals 40 degrees.